So, good morning, all of you. Today, we are going to start a new topic, which is called planning. So, in the planning, uh, we we are going to define that how an agent will do its local planning. It is just like, let's say, if we have a automated car. So, this automated car, how it will go from its source to destination, and what are the different actions it is going to take in between the routes, based on the based on what is the situation it got. So if there is a traffic, then how it works. If there is a signal, then how it works. If there is a vehicle just in front of it, so how it is going to do this, and in that way it will reach to the destination. So what is the plan that will be done to reach its destination? Another example, if we'll take the planning, is, let's say, we human being, let's say we plan to go somewhere. Let's say we want to go to Simla, or we want to go to Manali, let's say. So how we'll go there? So from here we have to take a plane, or we have to go by a train to Delhi, and from Delhi we'll take the bus and we'll go to this Manali and Shimla, and we book the ticket for the hostel and all those things. So this is the plan that we actually achieve. So planning is nothing but set of actions, right? So in once when we do the planning is nothing but we take it as a set of actions. Now come to the definition of it. We have defined AI as the study of rational agent, which means that planning. Okay, rational agent means the agent which will achieve the goal with maximum profit and minimum cost, right? Means how it will get into the uh, profit. It depends on the what type of uh, environment it has. But rationality means how we think, how a human think. Can we make the robot, or can we make the agent to think like that? So that's why this planning is nothing but the study of rational actions, which means that planning, devising a plan of action to achieve one's goal, is a critical part of AI. So this one, planning is a critical part of AI, and here we are going to study that how an agent will find out the goal by taking different set of actions, and these actions are the taking this agent towards the goal. So this is the objective. So whatever action will perform, it is taking me towards the goal, and that's why it is called rational actions. So rational actions means it is taking towards me towards the goal. So whatever actions, let's say if I have to go from here to railway station, so what are the action that I'll perform that will take me towards the towards my goal, right? And my goal is to reach railway station. So what are the different actions that I'll do in between is nothing but the rational actions. Okay, so till now we have seen two example of planning agent. So the first one is search based problem solving agent. So all the searching algorithm we have seen till now, different type of searching algorithm we have seen, like informed search, uninformed search, and different categories of it. And then we go on to another type of planning agent, which is called logical agent, which has the prior knowledge, and based on the percept, it will choose what type of action it has to perform based on the inference system, right? So the logical agent also we have seen, that is called your knowledge base agent. This is another type of system which is called planning or the planner, and it is very much useful in every area of AI. Let's take an example of spacecraft, and let's say if we are sending a spacecraft to from here to Mars, let's assume that. So, or here to, let's say, the moon, and the spacecraft has safely landed into the moon or into the Mars, and then we have some predefined actions or predefined goal that this this spacecraft has to do, right? And what we do is we when we want to send a signal, or we want to send any type of communication, or we want to give any type of command to give this particular let's say the spacecraft. So definitely from here to moon, it will take a lot of time, that we know that. Let's say the signal is taking 20 minutes, or the signal is taking, let's say, um, half an hour to reach from here to moon or to here to Mars, let's say. So we cannot do the actions which are there in locally. So the local action has to be performed by the spacecraft. Let's say it has to do a specific task to collect some samples, to go from one place to another place, let's say landing place to the sample place. So all these things it has to do by your own, and this planning has to be done by itself. So this set of actions, so the actions are defined, but which action has to be take after one step, then after one action, which action has to be taken. So in that way it will reach to a goal. So that sequence of action is called plan. Okay. In this particular chapter, or in this particular topic, we introduce a representation for planning problems that scales up the problem that could not be handled by those earlier approach. So here we are looking forward to solve some more complex problems that cannot be handled by the previous techniques, and we try to achieve the goal uh, by this particular technique, which is called planning technique. So till now, what we understood about it. So we have understood like planning is a reasoning side of acting, right? And this plan is nothing but a sequence of actions. So let's say, okay, let's say I'll take an example here. Let's say we have the word that we are talking about, right? So let's assume that we have the word or the environment. So let's assume that we have the word, and we have the agent, which are actually working in this particular word. So we have one agent here. So from the word, and this agent is also inside the word. Okay, I'm just putting it outside the word to just tell you that how it is happening. So let's say your agent is inside the word, and whatever a word is having means the sensing, the environment changes and all these things will be perceived by the the agent. So the perception will be done. So what it will do is it will perceive. So from the word, the agent will perceive something, and it will understand it, or it will reasoning it, or it will what it will deliberate it. So it will deliberate, and then it will perform the actions. So it will act on it. act on the word. So based on the percepts or based on the sequence of perceptions, now the agent will deliberate or agent will understand that what action has to be done and it will act. So it is a normal agent that we have seen till now, right? But here what we are expecting a system which is called a planning system. Let's say we have a system here in the environment which is called planning system, and this planning system will actually act for making the decisions to achieve the goal. And we have some executive which will execute, our plan. So we have an executive, and this executive will work on again the word. So what we have added here is we have added here the planning system. Now we have the word, we have the agent will perceive something, and based on that it will deliberate, it will find out some understanding and it will act on it. But here we'll add a planning system apart from that, so that whatever action it will take based on the planning, it will execute those particular actions into the word. And what we are assuming is once we are in the environment, so environment is not going to change, so any changes are not allowed here in the environment when we talk about the planning agent. So the environment is static, only agent is acting on it. Okay, only agent is acting on the word. Let's say if we'll say, let's say the environment where there is no rain, there is no cloud, there is no sunset or sunrise, means your word is static. Everything that we have chosen is static, and the agent is going to work on it. So the agent is going to act on it based on the perceptions what he got with the a system which is called planning system or the planner. Okay, so this is how we visualize a planning system in AI. So the planning is nothing but the reasoning side of acting. Means we are doing the acting, but we do the acting based on the reasoning. So based on the reasoning, we do the acting, right? We do the act into the environment based on whatever we have perceived. So what are the thing which I told you just now is the word is static. There are some sequence of actions. So the actions, you can say the state space will be taken as a static one. So the state space is static one, you can understand. And you have finite number of actions that we have. So we doesn't have infinite number of actions. Next thing is we doesn't have to bother about the timing. So let's say we just have to bother about the sequence of actions. So one action will be performed, and after that this action will be performed, after that this action will be performed. That sequence of action we have to look after. We doesn't have to bother about actually the time, that at time t1 what we have to do, at time t2 what we have to do. No, we just have to bother about the actions sequence. Okay, and here in this particular course we are going to understand the plan, and this plan is nothing but was what I told you is sequence of actions. So in the planning system, we are going to do the following. So what we are going to do for finding out the sequence of actions. So first we are going to do to understand is domain description. So whatever domain we have, whatever environment we have to understand it fully. So full knowledge of the of the environment should be there with the agent. The second thing is action specification or action description. So uh, what are the legal actions that can be performed into the environment? That action has to be specified. So without that you cannot do anything. Let's say you want to play the chess game. Let's say let's try to deliberate this with the help of this example. Let's say I am new with the chess, I don't know anything. So if I want to play the chess game, so what I should know that what are the different um, pawns are there, how they will move into the chessboard, what are the different constraint it has, what are the different legal move that they have. So I should have the domain description, I should have the game description, right? So if I'll play one move, so my opponent will play after that, then again I'll play. So that I have to know. I should know what is the meaning of checkmate. I should know what when my queen will be no more in the game. So definitely I'll lose my game. So all these things I should know, right? So these are called domain description and action specification. And what other part we have is we have the goal description. So whatever goal that we have to achieve, that will be described fully. So that also we should know. So that my goal should be described um, very, you can say precisely, so that an agent will understand that what it has to achieve. Okay. Now the first planner that has been made in early 90s is a robot called Sheki. Sheki is a robot that has been made by the Stanford University, and this Sheki is the agent that they have made is just a type of robot. And what it will do is it will just find out the power sockets to charge itself. Okay, so it will go into different means it will if it will find obstacle, it will just um, mm, take some actions. Let's say if it is roaming around the office, or if it is roaming around the home, so it will go on and it will find out if there is an obstacle, it will go to other path and find out the socket to charge itself. So this is a normal or a very simple agent that they have made. They have made different sort of actions with them, and which action has to be performed, it is based on this agent. So in early 90s, the Stanford University has made this agent called Shiki, and they have made this planner, which is called the first planner related to AI. It is called STRIPS. The full form of STRIP is Stanford uh, Research Institute Planning System. So STRIPS, in short, they said that it is a planner, and this particular planner will be putted into the agent, the robot called Sheki, to do its actions, set of actions to reach the goal. Okay. Now here in this particular course, we are going to understand some advanced part of strips, and that we are going to see, which is called uh, planning domain description language, which is called PDDL, that we are going to understand near future. So I think till now you have understood. So what we are going to do in the planning system, we are going to describe the domain, we are going to specify the actions, and we are going to describe the goal. So all these things would be there with the agent. so that a agent will work based on the word perception and based on this planning system that we have just seen, this planning system, and do some actions. So in the planning, researchers have settled on a factored representation. Factored representation means there are different modules, and these different modules are act with each other, and they are not independent, they are dependent with each other. One in which the state of the word is represented by a collection of variables. Here we have different sort of variable that we'll use, and these variable will be used to represent any state. So any state in the set of actions that we have to achieve from reaching from initial state to the final state, or the initial state or the initial position of the robot to the final position of the robot, we need to represent it, and we'll represent it with the help of, now what we have, different type of logics that we have learned. We have learned the predicate logic, we have learned the propositional logic. So based on that, we'll just represent it, and we'll use some sort of variables to do that. Okay. And here we are going to use the language called PDDL, which is called Planning Domain Definition Language. So in the previous slide, you have just seen that what we are going to do in the planning system, we are going to understand domain description, action specification, and goal description, so that all these things can be represented with the help of this PDDL, which is called Planning Domain Definition Language. And with this particular PDDL, we are going to describe all those things. Here we can describe 4 things based on this PDDL, and we need to define in the searching problem. So first thing is we can describe what is my initial state with the help of PDDL. We can describe the actions that are available in the state. So what are the actions that we have in one state that we can define? The next, we can define the result of applying an action. So after applying the action, what is the result that we can define, and we can do the goal test. So all the time we can do the goal test, and we should know what is goal. Then only we can do all those things. So in the initial state, we are in the initial state. We know what is the goal state. We should know that what are the available action on the state, and when we perform any action, what is my result. So all these things can be represented with the help of PDDL, which is called Planning Domain Definition Language, and that we are going to see in this particular course, that is PDDL. And in the PDDL, there are many versions of PDDL. We are going to understand the version 1.0. And this version 1.0 is the advanced version of strips, okay, that we have just seen, right? So strips is nothing but Stanford Research Institute Planning System. It is called strips. So this is advanced version. Strips advanced version is called PDDL, and PDDL's first version we are going to see here.